Good morning and good afternoon to everyone today who is attending our webinar. We are so excited to have you all to join today's session, which is Mine Planning and Management. We are joined today by Kevin Smith. If you probably seen him lots of times, but you might not know his background. And of course, I'm Gels Manlangit, the marketing girly here at Propeller, but I'll pass it over to Kev first just to intro himself, a bit about his background, why he's the perfect person to present today's webinar.
Yep. All right. Thanks, Giles. Kevin Smith. I'm the regional sales manager here at Propeller. But yeah, my background, I am an ex-mine surveyor and mining engineer. Spent lots of times in mining, different mines across Western Australia. And yeah, pretty much a lot of the tools when drones weren't around when I was doing mining. And it probably would have saved me a fair few 100 kilometers every week of walking if I could have access to drones and the tools that we've got today. So yeah, really good, advances have been made, and yeah, hopefully run you through some of those best practices today.
Sweet. Yes. So before we jump in, just a little bit of housekeeping. So we do have a dedicated session at the end. So you'll see at the bottom of your Zoom bar, there's the Q&A. You can just press that, type in your buttons. You don't have type in your buttons, type in your questions, and then press the button to go send in, and we can answer them at the end of the session. If we don't get to it, we'll definitely get to those questions via email. This session is also recorded. So if you need to jump off early or you have a colleague that you want to share this to, it'll be in your inbox within the next 48 hours. Other than that, we can dive straight in. So over to you, Kev.
All right, thanks, Giles. So today, really want to run through, how Propeller can help with the mine planning, management, but also run you through, the best practices that we've seen across the globe. It'll be a session interactive, but run through, not just the survey side of things, but how other departments are also using Propeller and the tools to help with their day-to-day mine and the jobs, and also the mine planning as well. So Propeller at the moment, we're on 1,800 plus mines and quarries every day they're using us, and it ranges from the surveyors all the way down to, you've got the quarry managers, environmental teams, pretty much everyone who's involved with any mining operation at some point in the day-to-day work will touch on Propeller. We currently process 20,000 surveys every month, and they're uploaded, processed. So, we do know, best practices based on how many customers we've got and how many surveys we upload. We know what works, what settings works, what don't work. We've learned this throughout the last 10 years of looking after mining and quarry customers. So that's what I'm going to run through today, and run through some of the best practices that our customers have. So this is like traditional workflow. So on the right, this is what happens pretty much on a day-to-day basis. This is exactly what I would have done back in the day. So you've got your traditional workflows and this is for, we're looking at drones to start with here, but it could be any other normal surveys as well. But you've got ground control points that you have to survey in. You've then got a geotag drone images. All of this has then got to be moved to MineGrid or your local grid. You mark up the GCPs when you've flown the data, so you've actually got to manually mark up those ground control points, then process the data. Then these three things at the end, like analyzing data, you've got how do you share the data, and then where do you extract the data to. So this is drone side of things, but it can be now normal survey. So you can see each one of these typically has and traditionally had its own software. So, you've got your rover surveys for here, geotagging, the specific software that can do geotagging for PPK. Shifting to MineGrid's another one. The processing the drone data is another bit of software. Analyzing the data, again, goes to whatever software you're using, mine software to analyze that data. It could be GIS software. Then how do you share that data? Is it Dropbox? Is it internal? And then how do you also extract that data? So we're looking at 1, 2, 3, 4, 5, 6, 7, 8 bits of software to just be able to extract and use that drone data or survey data. So this is where Propeller comes in. Literally everything on the left-hand side can be done with one bit of software with Propeller. The GCPs will run, we've got our own error points, which is self-surveying ground control points. We geotag the images automatically when you process the data. MindGrid, that's a drag and drop. It's already done for you. If you've got a GPS rover survey with a calibration, you drag and drop that calibration file into Propeller. We're already on that MindGrid. We automatically mark these for you. We automatically process the data, and that data is fully QA'd, and you can choose what kind of filter and what you want with that data as well. Analyzing data is the bit that I'm definitely going to dive into today. Sharing data is literally a one button click exercise in Propeller, and extracting the data again is a one button click exercise. So we're looking at 8 bits of software. So when you're trying to work out the value of, what does Propeller bring to the table compared to other software, we are literally comparing 8 softwares to one as well. So I'll dive into like the best practices. That's sort of the sales pitch done for Propeller, and we can dive into the best practices. So this is an example from a couple of mines around the world who I've been talking to. Let's say it's this is going to be on a large open cut mine that I've been dealing with. So they do 5 to 15 drone surveys a day. It's a lot of surveys, but they're moving a hell of a lot of dirt, which you do in mining as well. One of the big things that certainly helps like with these mines, and the one thing they've also got in common, is they've got different drones to suit the different needs of what they're doing, but they've also got high-speed comms throughout. Now, one thing that has definitely changed and helped is it used to have to be Wi-Fi across, which is an expensive setup across your mine. What we're finding now is that Starlink Mobile, especially on the surveyors' cars, are certainly helping all the environmental teams so that they've got connectivity wherever they are. This has been one of the game changers, especially mining and for cloud-based systems. So what do they do? To capture data really well, they've got a larger drone survey for the month. This can either be done with a fixed wing drone, or we've got a fair few mines using planes to actually do this. Then they've got a small drone for the daily operation. So this is the areas of change. They'll use this small drone to fly. Then they've got an arrow point to use as the ground control and using PPK, or they'll use RTK and put one ground control point down. And I'll run through the workflow a little bit later. Then we've got Propeller accelerated processing. So this will give you average turnaround times, 1 to 2 hours, very comparable with your standard laptop processed or desktop processed surveys. And one of the other things that we've introduced just recently is that we can now bring GPS rover surveys or total station surveys or even LiDAR surveys into this mix as well. So we're no longer restricted to just drone surveys. If someone, let's say, has picked up this little stockpile with a rover, you can integrate that into your large monthly flight as well. So what do they do? So essentially, this is one of the workflows. They'll survey the area of change every day. So they've got the monthly survey. They'll survey that area of change. And then let's say it's a drone survey. They'll have multiple surveyors flying the areas of change in the morning. They'll process that data. And because they've got high-speed comms or Wi-Fi or Starlink, essentially they take the SD card out of the drone while it's still down in the pit, drag and drop it into Propeller. And then as they're driving up the pit, the drone data is automatically being processed. It's being processed in the cloud. And this can be, 3 or 4 survey teams doing this all at the same time. And so by the time they get to the top of the pit, or there's a surveyor at the top of the pit, they can actually combine all those surveys into that monthly survey to have a working model of the mine site every single morning. So we've got a composite thing called composite surveys. It's literally, I want to combine this survey, this survey, this survey, hit a button, it stitches it all together and you get a full working model. Now, this is where it comes in very handy. If you've got your morning planning meeting, everyone in that mine site now can be looking at a 3D model that was captured an hour or two ago of the entire mine. So if an engineer wants to know how much did we move in this area here, they've got that information there from every single day to go, right, I moved this amount of dirt from here to here today. It's a very streamlined process. It's very minimal sort of work, and it allows the surveyors to capture lots of areas very quickly and have it all as that one working model. So, and you're looking at maybe sites were flown at 8 o'clock. They've got that data ready to go across the whole mine by 10 o'clock in the morning. So who uses that data? So that's how, best practice for capture. Who uses all this information? Now, Propeller is very, very easy to use. So who is using it? So just on one mine site, we've got 400 plus users on the one mine. Now, that ranges, as you can see on the left here. We've got the survey team, which is pretty obvious. We've got the engineers, and these range from, the planning engineers, the production engineers. Everyone has got access to that data. We've got the geotech teams who can then have a look and look at, let's say there was a slip overnight, they can fly that area and check how much volume changed straight away. Geos use the data because it's full 3D data from the day before. Tailings dams is a great one. There's no easy way to capture tailings dams. Drones are perfect. You can see the cut and fill volumes. Environmental teams, foreman, management, head office, even because it's cloud-based, it's very easy to share data. Exploration and the safety teams. And what we've certainly found is many departments have got their own small drone and arrow points, and they've been trained up by the survey department to go and fly the areas they want and need, so that I was a production surveyor, and you're flat out working in the pit nonstop. If an environmental member comes over and says, I want this area surveyed 10 kilometers away, it's very hard to fit that into the schedule when you need to work on the production. So this is why some of these teams, and it's it's minimal cost to sort of get these drones compared to the value you get out of it. It means that these teams can go and fly their own survey. Arrow points make it very easy because it's literally one button push to capture your ground control, but it also acts as a base station for the drone. And they can drag and drop, and there's literally, as long as you can copy and paste, you can process drone data. That's how easy it is. And that's why a lot of these teams have got their own drones to supplement the work that the surveyors do as well. All right, so I'll dive a bit more into those different departments and what they do and the value they get out of Propeller. So from the survey department, we've got different options for how they want to process the data. So you can do full processing through Propeller, we can do full photogrammetry, or we can process LiDAR, and that's literally the drag and drop. We do all the processing, and then within an hour or two, you get a full 3D model, which is all QA'd. If you want to use your own drone data, you can do that. And you just drag and drop your own processed drone data into Propeller, and you've got the full working model that you've processed yourself. We can now bring in GPS rover, total station, or LiDAR scans into Propeller. And like I mentioned before, either have them as their own separate survey, or you can stitch them into the drone survey as well. So, if there's areas under tree cover that you can't get to, things like that, you can use a total station or a rover to go and capture that area and stitch it into the model. And pretty much everything. So where it comes in very handy for the survey team is if you just want to get a very quick snapshot of something like we've got on the right-hand side here of we've got the design, and then we've got the actual in here. It's literally 2 button clicks. You click on the thing that says cross-section, draw a cross-section, it gives you your answer you want. And then to be able to share the data, it's great. Now, one thing for the survey department, it's a supplementary tool, like I'd say. It's something to get quick answers very quick. It doesn't replace your standard survey, your mining software to do the complex tests like splitting volumes by bench and payment terms and things like that. But what it does do very well is get these answers very quickly, pretty much quicker than any other software out there. The other thing that is definitely a massive bonus, and I wished I would have had this when I was a surveyor, is where it comes in very handy is it frees up your time because all the other departments can actually go and get a lot of the answers themselves. So if an engineer wanted to do this cross section, they can just draw it themselves. If an environmental team wants to see how much clearing has been done on an area, they can literally draw a boundary around it and get the clearing themselves. So where it comes into it is essentially, I'm a supervisor, I want to know the grade of a road. They can click on the grade of the road themselves instead of having to come to you to answer those very simple questions. So I'll dive into some of the other ones. So engineers, where do they do? Daily production volumes, literally up here, you can draw a boundary. It will tell you that survey, how much have I moved today from one survey to another survey, give me the cut fill. What we can see on here is the yellow and red is cut and the blue is fill. Where it's clear, it hasn't changed. Now, again, surveyors can do this, but let's say I only wanted to know this cut area. Instead of you having to go to the surveyor to say, right, what is the change in here? You can just go and draw the boundary yourself as an engineer and get that information. If I wanted to check what my slope or my butter was compared to a design, again, you can do that yourself. Road grades, exports, again, perfect. If I wanted to export this, because I'm going to redesign this area, drone data and survey data, especially drone data now, is very, it's huge amounts of data. Like we're talking sort of gigabytes worth of data here. Instead of using the entire model, I can draw a boundary and extract just the surface from inside that area with literally one button click. So instead of having to go to the surveyor and say, I need this little section here, and you've got to explain or draw a boundary work, you can do it yourself and then just go export, and it will export the surface just inside that to then go into your mining softwares like your Vulcans and your Serpacs and your Deswigs. Tailings dam management, perfect. Like I mentioned before, you can fly a drone. You can do this cut fill to see where things are moving. Waste dump management. And then one big one is our new hydrology feature, which is this water runoff, and I'll dive into this a bit further on where you can see some of the other tools. But what you can see here, it simulates where water's going to flow on your site. And where this comes in handy, before it rains, you can actually see like this section here. Where is water crossing over my haul road and where you might have issues with cross slope. So before it rains, if you're not going to have a rain event, you can have a look and say, right, we've got a cross over here. This is going to get washed away. What if we change the cross slope across from left to right so that all the water runs down the inside wall instead of the outside, and we have that crossover point. So very, very handy feature. Again, you can also run this and see where it's going to start spilling over your batters as well. Geotech department, obviously get all the other tools above, but we've also got this thing called vertical face imagery, which essentially gives you a true realistic model of your face, of your high walls, where you can see faults, you can see your cracks, you can see slips very, very clearly. And again, you can run this water simulation. Geologists, where it comes in, obviously we can do very easy stockpile measurements. It's again one button click to do stockpiles. Where it also comes in handy, we do have a Propeller mobile app, and what the mobile app shows is your location on your phone on the background map, but you can also overlay design lines or geology on there. So let's say this white line up here was like a fault zone. You can use your phone and it will show you your location in relation to this fault zone, even if it's underground. So again, very handy. You can take photographs, and this is good for geotech as well. If you take a photograph using the mobile app, it will automatically appear back in the platform at the location you took it as well. So this is where it gets into, it's a survey tool, but it's also a GIS tool. We're sort of a mix of the two together. All right, tailings dam management. This is very handy. Obviously, you can see up here, we've got a tailings dam. You can customize heat maps. It will tell me the volume that we've got on here. So this is from one survey to another survey. And what it's essentially showing me, the blue areas and the darker blue is where it's filled up more than the other areas. Where it's clear, we haven't done anything. Where it's yellow, it's where it's actually been lowered that's probably because that was water sitting in there and the water's evaporated away from one survey to another. But you get a very good snapshot of exactly what's happening on this tailings dam, and with literally one button click. Now, if you wanted to share this with someone who's managing the tailings dam, all you need to do is click a button that says share, and it will bring out a web address. You send that web address to them, and that will share that information straight to them. We got full reporting, but if it's internal, you just share in a web link, and anyone who clicks on that can then view that information in 3D. And again, you've got the hydrology tools. We've got all the civil tools that we have. So if you're building doing a new lift on a tailings dam, you can fly the drone. You can tell how much volume's been moved from lift to lift. Very handy if you're paying contractors, because it gives you a very good snapshot and an idea of how much they're moving when building that tailings dam. The mobile app for supervisors and foremen, we're down here now. Very, very handy for them. They can actually go and do volumes, stockpiles themselves on your mobile phone. You can do windrow checks, height checks, but the mobile tools essentially allow them also to view 3D designs. So you can load in a 3D design on your phone. It will show them their location of where they're standing, but you can then say, okay, this ramp starts here and this ramp toes down here, and they can visually just walk around and see where it starts and where it ends, all in 3D. You've also got the photos again for record keeping and safety, which are very handy as well. Environmental teams, this is definitely one of the big use cases for Propeller in mining for rehab management. It's very handy because you can fly a big area very quickly. As we mentioned, we do have this timeline feature. So that's essentially overlaying every survey on top of every other survey, and you can use the timeline to go back in time and see how things have changed from survey to survey to survey. So if you want to see what clearing has been done, you can use that. If you want to see what's happened from a big rain event compared to now, you can go back and see what it looked before and what it looked like after. And then what you can see up the top here is our hydrology tool that allows you to simulate what water is going to do on site as well. So, and I've got a video showing this later, but very handy, very easy. And again, we do have lots of environmental teams who have their own drone as well, because they can then go out and go and fly off-site or off the production site to go and fly areas that they want information on. Safety teams, again, the mobile app comes into its own. We've got an image down here where you can actually just do the checks of the windrows. You can take photos. One thing you can also do is check road grades very quickly, and you can do road grades across the entire site very quickly, again, like a couple of button clicks. And the safety teams can then highlight which areas of concern. If you've had a slip, you can check the volume of what's fallen down in that slip. You can have lots of sort of simple tools that anyone can use, like one button click, but gives very valuable information. And again, we've got export features. This one is just a screenshot straight from the platform that you can actually visualize, and we've now got a thing called markup where you can actually write and draw on these things as well. Head office wise as well, so if you're dealing with head office, the one thing is great because we're cloud based. Again, you can just share a web address and everyone can be using that same information. So the timeline feature, we can see how things have changed over time. Safety incidents, I've seen this numerous times on mines where the head office is talking to the mine site all about a safety incident, and they can all visualize it all in 3D. They can see exactly what's happened. You can check road grades, slopes, slips. Very good for planning, and especially lots of these mine sites are remote, so you can work very collaboratively with head office and with site to make sure everything is done correctly. Also very good for the design collaboration as well. If the design is being done offsite, anyone can draw a boundary and extract the information they want to put into their design packages as well. All right, now I'm going to touch on something that's fairly new for Propeller, which is DirtMate. This is a machine tracking system. It's a GPS unit. And where it differs from your typical machine systems is it's a GPS row, a GPS antenna that mounts. It's probably about 5 minutes, 5 to 10 minutes to mount on a machine. What it does, it uses the GPS to show us where the machines are, but it's also an RTK slash PPK antenna. So what we're doing, you measure the height and the width of the machine, and as the machine drives around site, it's also capturing the ground that it drives over. So it's essentially turning every machine on site into a GPS rover. And that way we can actually do volumes from DirtMate as well. So we not only need to have the drone survey and you can have rover surveys, we can actually have all the machines capturing live data as they drive around site. So let's say it's a front end loader, it's driving into a muck pile. We know when he's driven over it, we then stitch that surface into the drone survey to let us know what that surface change is, and then we can do volumes and create surfaces from that. So this is what it looks like in the browser. It's all embedded. We've got a machine tab down here. And what it will do, it gives us the production tracking, which is the volume. So on this visualization here, this is essentially showing me what they've done for the day. This is the end of the day. It shows me the trails of where the machines have been for the day, but it also shows me the blue is fill and the red is cut of the volumes they've moved for the day and where they've worked. But also, we've got the added bonus that we also do automated load counts and dump counts and cycle times. So because we've got the tracker on, we know that a truck is next to an excavator. So we say it's done a load, and you can draw geofences to where your dumps are. That then allows us to do things like this. It's done 65 loads and 61 dumps. And it breaks it down into how many loads per hour. You can do this daily, weekly, monthly. It not only shows me how many the trucks have done, it gives me, the average haul time, the load time, the average dump time, and the average length of that haul route as well. And then you can also break it down into which excavator it went to, and it will tell me which excavator and which dump that load went to. This excavator, which dump, and if I clicked on the dump, it will actually tell me from that dump how many loads went into that dump zone and where it came from as well. So it's a full machine fleet system, but with the added bonus of also giving you volumes. Every 30 minutes, this surface updates from what the machines have captured, which allows you to also do our normal propeller measurements, which are cross-section volumes. But instead of doing it from the drone survey to drone survey, you can do it any 30 minutes to any other 30 minutes of the day. We've also captured machine utilization. Now, all of this is without plugging into the machine. We've got an IMU on the machine that allows us to capture this information that will give us the off time, the working time, and the idle time of the machines as well. So we sort of get the best of all systems. We're getting volumes, we're getting load counts, cycle times. It also works on scrapers, and we also get the machine utilization, all in a 3D model that's been captured, visually looks correct because we're using the drone survey as well. If you fly a drone survey, we will basically wipe the slate clean and you start afresh from the new drone survey as well. Added bonus for the supervisors is you can do all of that on your phone as well. So we can go in, we can see the locations. The machines are live. We can view live locations of the machine and the live productivity of where the machines are. So it'll tell me the runtime, idle time, and it will also tell me how many loads and haul length and everything as well on your mobile phone. Also, like I mentioned, we capture the surface. So if this is a rehab job here, if you've got the design loaded up, every 30 minutes, you can view what your surface looks like compared to the design. And this is essentially doing it on your phone. You just click a button and away you go. Also with utilization as well. Now, on top of that, we also get daily emails. So you can set up custom daily emails that will give you a summary of what the day before has done. So as I go into here, you can see this is showing me my volume as done for every day. I can look at custom zones and tell me the volume that have been done. I can look at the trails and what loads have been done and where they've come from. And essentially you can customize different emails for different people. And every morning when you come in on site, you get an email that shows you what you've done for the day before. So if people don't want to go into the app or go into the platform to analyze the data, we get a daily email that gives you a breakdown and a summary of exactly what happened the day before as well. All right, now I'll show you some of these workflows in action. So this is the rehab on a waste dump. So essentially what you do, you click on the tool that you want. So I'm going to click on compare to design up here because I'm going to compare this to the design file. You draw a boundary around the area you want. And that will then, you then choose what design you want. So I'm going from the current surface to the design that I want, which is this one. And that will then tell me the cut fill instantly on where I am compared to the design. So we've got 10,000 of cut and we've got 23,000 of fill. The blue is fill and the red is cut. And in this instance, basically the red is where they've overfilled this area. So very quick, very easy, literally click on what you want, draw your boundary, it gives you the information you require. And again, you can create reports out of this, PDF reports, you can do full cut fill takeoff reports where you can do a grid spacing that will tell you the cut fill between each area as well. And if you hover your mouse, it tells me the cut fill. So it's saying cut 2 meters, cut 1.3. Now, to do cross sections is almost identical as well. You literally come in, you can turn your design file on. So I'll just go in and turn the design on. So we can see the design in 3D. I go to the thing that says cross section and literally just draw a line down the section I want. And it will give me the cut fill between the design and the surface. Yellow is the current surface, blue is the design, and it will then show me the difference between the two. So we've got 1.3 meters of cut at that section there. If I wanted to change it to like a tangential offset, which is handy when you're doing steep batters in a mine, you can see my slope is, it's a 1 in 4 slope, and I've got 1 meter of cut. Now, this one dives into the water catchment. So essentially what you do for the catchment area with our hydrology tool is you draw a boundary and then you run a simulation. So we've got a catchment zone, the yellow dotted is what you can see. When I run it, it actually gives me a stream network. So this joins up, when I had that surface runoff before where you could see the water flowing, this one sort of joins it all up to show me where water's coming from and where it's gone to. It gives me flow directions as well. And with this, it also allows me to then pick a particular spot, let's say down the bottom of the pit there. I click that and it will then give me the catchment area for that location. So from that location where it says outflow point, I can see that blue area is where all the water is coming from that particular location. Now, I know I'll probably get a question on this. This is assuming there is no absorption rate. This is essentially assumes everything is concrete, but it gives you a very good idea of exactly what you need to do if a rain event's going to occur. What also allows you to do is you can see how the water interacts. So we've got a yellow stream coming down here and then going down and flowing back in. If I want to redirect that water, I can see I just need to put a channel in this section here, or again, put a channel in down here to redirect all that water away from the area I want. So it's a very handy way to pinpoint the areas you need to target to redirect water. And again, there are very sophisticated hydrology tools out there that allow you to do flow rates and absorption rates and all sorts of things. This is essentially saying, right, we're going to have a rain event tomorrow. What do we need to do so we don't get flooded out? And it's based on what the topography looked like from your drone survey that could have been 2 hours ago. So other thing that gets used, because we've got the square meterage, you can also work out, what size pump you might need down the bottom. If you times by the millimeters of rain in that square meterage, what size pump and flow do we have coming into the bottom? All right, now the last one, this rain simulation, this is where we get fancy. So we can upload a CSV file, and the CSV file, just getting blinded here. All right, the CSV file, it's a very simple CSV. It's in the left column, it's just your hours, and in the right column, it's the millimeters that you're going to have every hour. It produces a graph down the bottom like this, where we've got a peak rain event. These are two different rains that's going to come in today. And as I run the simulation, this will then go through and show me where water not only going to flow, but where it's going to start pooling on your site. So as I go through down the bottom here, you can see as I go through where water will start pooling. So as I pause it here, we can see, we've got drains down here where it's meant to go, but we can see how water starts flowing and interacting with each other. We've got a low spot happening here. And because there's no drain in here, we can see how water builds up behind this road. And as I go through, we can see we actually get to a point where, if I run it through up here on these batters, this is a rehab job. We can see where water's pooling on your site, but also where it's going to start spilling over your batters as well. So as I zoomed in, you can actually see on here, that's what's actually occurred up this particular job. So if you've got topsoil and you're going to have a rain event like they're doing here, we've put our topsoil in, and then it rains, and we're going to have all our topsoil down at the bottom of the ditch. So this is a very good way to plan and say, look, we've got a low spot. Let's put a bund in here or cut a channel and create a drain so that all this water then flows. And we can see, on here, it's flowing and down. This is also very handy when you run this in a pit and you've got all your berms. You can view and have a look where water's going to start pooling on your berms and then where it's going to start spilling over. So very handy for the geotech teams where you're going to have problem areas in your mine when you have a big rainfall. Because it does the exact same thing. It pulls up on your berms, and then once it reaches a certain elevation, it will start spilling over. And again, you can be doing this off a survey that was done literally 2 hours ago. Very handy, very good for exploration, lots of things, even any civil works on site using this particular thing. So that gives a good rundown on sort of the best practices. Probably the biggest thing to take away is Propeller is designed for everyone on a mine site. Every department gets their own type of value out of using these tools, and it's a very easy way to collaborate and share information between teams without having to dive into the deep dive of all those survey, the specific mine and softwares as well. So yeah, I'm ready for some questions if we've got any, gels.
Sweet. Thank you so much, Kev. So yeah, definitely reiterating like the collaboration hub of Propeller as like your GIS software, combining GIS and survey. We do have a question from Ayobami asking, is there a way to measure horizontal movement displacement within structures in addition to the vertical movement, such as cut fill in stockpiles or cross sections when comparing surfaces using Propeller?
You can't really do that at the moment. You can manually do it because you can use the timeline to see what it looked like before and after, and you can manually measure point to point to check that horizontal movement. I've done that lots of times. Blasting's a great example because you can see what the face looked like before. You can see where the heat spoil where it's gone to, and you can then manually move from going from, right, this is the face now, this is where it's got to now, and we can check that distance of what's changed and the throw that blast has done.
Brilliant. And we've got another question by Hussein who said, like, on the he saw like sometimes he sees like a blurry area image. How do you control that when you're in platform?
What's that? Sorry, when
a blurry area image? How do you control that? Maybe it's like the vertical face imagery if he hasn't got that turned on.
There's two things. So one, if it's blurred when you're zooming in, it could be the internet speed isn't up to speed where it isn't loading the tiles correctly. If it's to do with the vertical face imagery, where you get the blurred images on your faces, that's essentially something that happens with photogrammetry. If you want to remove that blurred image, we do have the option which is called vertical face imagery, which you click on as you're processing the data. We have to process the data, it can't be pre-processed. And that then overlays the realistic photo on those vertical faces to give you the true image of what it should look like. It does take 2 to 3 times longer to process. And if you do want to get some really good data on that, you can do oblique images to capture those faces and upload that with your normal survey to get really crisp, clear vertical imagery on there. But it is a specific button that you've got to click for processing.
Yeah. And then also in that, Luck is asking, why do we got to turn it on? No, he's asking, why is the vertical face imagery option not always on when we're surveying or uploading data? Which I think you kind of touched on, but if you just want to reiterate, Kev, like just how big it is.
Yeah, it's an option that we can give to turn on. It's not on all the time because probably 90% of the time people don't want to use it. Geotechs definitely do. But the reason why it's not always on is because it does take 2 to 3 times longer to process. So if someone's clicked it and actually don't need it, we get lots of emails back saying, where is my data? I uploaded it yesterday. Why is my data not here yet? And it's because they've clicked the vertical face imagery and it takes a lot longer to process.
Yep. Brilliant. So yeah. And then you'll love this one, Kev, from Subhadeep. Can we detect underground obstacles using Propeller?
You can, if you've got the as a either an IFC model or as a DXF and it's underground, then when you do those cross sections, it will show you the depth to those underground survey, well, whatever you've got underground. So it's either got to be a DXF, it could be a DXF line, could be a DXF model, or it could be an IFC, which is typically like IFCs aren't used much in mining yet. They're definitely becoming the main sort of platform in the civil space. It's a full 3D realistic model that you can load. And literally, if you load that in, draw a cross section, it will tell you the depth to that underground, whatever it is, structure. On the mobile app, you can do that as well. So if you've got faults or whatever's underground, let's say you've got a void, if you have a section of that drawn up as a DXF on your mobile phone, it will give you your location in relation to that underground void as well. So it means you can actually share that with every single person on site and they can see where all the underground obstacles or issues may be. A good use case is underground services like power and water. You can load all of them in and every single person on site can have in the palm of their hand where all those underground services are.
Brilliant. And then we've got a question from Jeremy and Mark. We are mostly focusing in quarry surveying. What do we need to perform that? And also, if we do not have a GCP on site, can DirtMate replace that?
So DirtMate can't replace it as a GCP, but quarries, the workflows that I've just done is exactly the same as what you can do in a quarry. I would definitely recommend an error point if you don't have ground control. And if you've got a, depends what drone you've got, that error point can act as a base station for your drone. And that means your surveys, and I didn't touch on accuracy, but with the PPK and those, the Mavic 3 or the M350, we're looking at 3 centimeter vertical accuracy. So you definitely need ground control. Otherwise, depends what accuracy you're looking. If you're just using RTK, you're looking at about 80 to 100 mil, but PPK is getting you down to that 3 centimeters.
Yep. And like touching on the drones as well, Hussein had a question on the minimum requirement for the camera pixel wise.
Yeah. So 20 megapixels would be the go. Mavic 3 Enterprise, or now the Matrice 4, is probably the minimum spec you would want to go. That sort of size. Definitely RTK or PPK drone as well. If you don't have
Yes, and you definitely heard that. Yeah.
if you don't have a PPK or RTK drone, then you've got to have lots and lots of ground control. If you don't have ground control, your survey will be off by 6 or 7 meters.
Yeah, so definitely makes a difference. And I was just dropping in that, like, yes, Kev did say the Matrice 4 M4E
Yeah.
support, which probably people are asking about too, especially when you're capturing those smaller areas of change. But also in regards to DJI sensors, look is wondering the LiDAR technology implemented soon, which look, it's already there.
Yes,
Kev?
we can
Yeah.
process full LiDAR from the L2 or L1 sensor. It's again a drag and drop process. So very, very simple. You don't need to use any other software. I know there's third-party software that DJI tells you need to use, but you literally drag and drop your raw data into Propeller. We process that, and you get the full 3D model from your LiDAR, and we classify ground or unclassified. Yeah.
Yes, definitely. And then probably just the last one from Sarah here. Can we do scheduling with Propeller?
You can't necessarily do scheduling, but where it comes in very handy is that daily planning where you know exactly the volume moved from the day before. So you can use that to then, your plan your scheduling based on the volumes that have been moved the day before. So that's where it comes in. It's getting that very accurate, very quick volumes that you can use to then jump into your scheduling tools. Yeah.
Yeah.
And
And then just,
if you are,
yep.
sorry, I was just going to say, if you are a scheduler, you can do those volumes yourself as well. That's where it comes in very handy. Is if you're looking after a particular area on a mine, you can go, right, I want the volume here, and it will give you that volume without having to go to ask the surveyor for the specific area you want.
Yeah, so I think it's like really empowering the schedulers and the scheduling team with the knowledge to make those decisions.
Yeah.
Gregory and Mark just had another one. They are using the DJI M3E for this survey. If they'd like to survey a site with no GCP, can that be done? Which is like really a question of your accuracy. What
Yeah,
type of
it is.
accuracy? Yeah.
It can be done. Like if you're using it as, you definitely need like it's set up in RTK mode or PPK. You will be looking at about, depending on how high you fly, between 80 to 100, maybe 150 mil accuracy. So if that's good enough for you, then yeah. But imagine if you're surveying a big area, and you're 150 mil out, that equates to a pretty big volume over a big area. So it it really depends on what sort of accuracy you're looking for. Yeah.
Yeah, so it's you can, but it's about like what you want to get out of it.
That's
And then the last
exactly.
one we'll just end on. Yeah, for sure. I think like a lot of things that like you can do, but like when you're coming to accuracy, those little, even just like the 3 centimeters, like as Kev said, like over a lot of volume in the pit becomes up a lot that could be incorrect. So definitely for the production teams. But the last one that we'll end on is not a question, but just a comment from Gregor. Thanks, good presentation. So thanks so much, Gregor.
Thank you.
And thank you to everyone for attending today. It was an excellent session, such great questions. We hope that you've got like a little bit of a taste of what the day-to-day lives look like for some of our mining quarry customers, maybe some best practices that you can share with other departments. If you're a survey manager, let them enable themselves with all the knowledge because it is so easily clickable and shareable to them. And we will share this recording to you within 48 hours. So thanks so much, everyone. And thanks, Kev, again for joining today. Bye.
Well, thanks a lot.